Hello, everyone. Welcome to another bounty episode of the Day Zero podcast. I'm Spectre, with me is Z. As usual, the Spot the Vuln challenge will be covered in tomorrow's binary episode, and if you want to check that out, you can go over to our Discord and check out the Spot the Vuln channel. And with that said, we can jump into our topics. So up first, we have a Medium post by Two and Bose, which is a write-up of some Vulns found in an undisclosed forum, which had a Teams feature. So jumping straight into it, in this forum, you could create a team, and a user could request to join a team with any non-admin role, and then an admin and only an admin can approve the request to join. So, fairly standard setup. But there were a few bugs in that process when it came to the request level. So the first issue was the team and the roles were sent with object IDs to the team join post endpoint. And there was sort of an IDOR issue where you could basically just capture the role ID for the admin role and then replace the object ID for the role in the request for admin, and it would go through. So it was only really the front end that was preventing you from requesting joining as an admin. But if you tamper with the request level, you could get that through. So that would allow you to send a request to join a team as admin, which normally shouldn't be possible. Though that is a fairly low impact issue because obviously, if you're an admin and you see someone requesting to join as an admin, you're probably not going to accept that invitation. That's kind of where the more pivotal second issue comes into play.
No,
Um,
if somebody sent that to me, sounds like a fun thing to do.
just see what happens. Yeah.
Especially, I was wrong about this post actually, but I initially thought it was on like some sort of CTF platform. I think just because they mentioned working as a CTF designing consultant, and then it's a team issue, I thought it was something related to that. So I'm like, oh yeah, somebody trying to join my CTF team as an admin. Sounds like they might be a good member.
I jumped to
But
the same thing actually. I made the same mistake and then I had to reread it and it's like, oh wait, no, this isn't a CTF platform.
yeah, it's clear target is a form. So they do make it clear. We just
Yeah.
misread.
Yeah. I mean, it's easy because we always say that we like to see those like issues that target the CTF platform, so I think it's easy to jump to that conclusion with the way it was written. So but yeah, the more pivotal issue was the second issue, and that allowed you to approve your own join requests on behalf of the admin. And this was because the same sort of issue existed on the other side for admins. So in this case, it was the team and team member object IDs. And you can just swap these IDs in and accept any team member into any team, essentially, as I understand it, if there's a join request that was already submitted. So, yeah, some real meme bugs. And the impact is somewhat low, as ultimately it is like getting admin on someone's team on a form, but it's still kind of funny issues and they chain together nicely. And it's just another example of relying on the front end too much and not really enforcing validation on the request level. So, yeah,
I
thought we'd
would be
start off
sur-
with some pretty meme bugs.
yeah, I would be surprised if there weren't other bugs similar nature in this platform, given like just the blatant lack of any authorization check on the is approval, like doing that approved thing. It's genuinely surprising, but also I just noticed how they call these like underscore underscore type pointer class name and then the object ID. Maybe it's nothing, but, like, those names make me think there might be something with, like, serialization going on here too, like, maybe not necessarily a deserialization, but could you maybe point, say it's pointer to whatever class, but actually point the object ID somewhere else, that sort of attack there? That API, that interface just seems kinda weird to me. Um, it's probably nothing, but I don't know, the whole thing's vicious.
For sure. All right. So, continuing on the request level, we have a post called Fetch Diversion, and it talks about client side path traversal type issues with some real world examples in undisclosed targets. So, Z, you mentioned that we'd brought up client side path traversal before on a previous episode, which I'd kind of forgotten about. So, I'll let you get into this one.
Yeah, we actually covered it. I think it was episode 176. This practical client side path traversals. Trying to get the link to show up here. There we go. Uh, they talk about like a CSS case, but the gist of the bug, or this newer post basically, they're calling it fetch diversion, so giving it a different name, but same sort of bug. core idea is when you have some sort of parameter, say coming out of the URL fragment, maybe it's even stored in some cases. I think that CSS one had a stored value getting used, but you have some value that's user controlled. Um, Actually, that CSS one I don't think my bad on that because that would then be a self attack. Anyway, you have some parameter coming from somewhere the user controls. Um, and that gets used in crafting another URL. So in this case, they've got like the ID example here, and that's just being used to, or actually, that's not being used. That highlight, that's being used as like part of the API, pasted right into the URL, and then they do something, which is reasonably common to see, especially with the REST style APIs. Instead of using parameters to send like identifiers, they will just toss it right into the URL itself. And so you have the chance for doing some sort of path traversal attack there, which I thought was a interesting idea when we talked about it on the episode 176. In this case, they're looking at a few more relatively practical cases or likely cases where you can actually abuse this and just talk a little bit. They have three examples of actually abusing this sort of issue. But yeah, the core idea is very similar to just your standard path traversal where you inject, the dot dot slash. It's just you're doing this on the client side now. You're doing this in a URL so that instead of resolving this API target, instead of going to v2 users whatever slash profile, it'll go to whatever endpoint you actually want to redirect the request to. So you can have these requests hit other endpoints. Um, they have a few examples or a few exploit strategies for this. One being getting a DOM access with an uploaded file. The idea being there, you have some sort of file upload system. In their second case study, they use a image upload. You would upload your image. It would be sent back to you as like application. Get exactly what the header was. Application binary would be sent back there as that, but you could fetch that. And being an image, you could just upload basically whatever content you want. There were some client side constraints there, but most of us know those don't matter. The only real security is what's actually happening on the server. Uh, but effectively, you have a file upload. So if you can redirect any post or not any post request, any API request, any fetch to your uploaded file, now you control the response to all of that. Can you do anything with that? Perhaps, perhaps not. They did have one kind of cool trick they use here. It's nothing too crazy. I know other people have done very similar things, but still, the way they went and found a source for their DOM XSS was by using basically a find and replace inside a burp to replace every JSON value with XSS payload. I don't know. I think I've done something similar with like a proxy. I would just write my own little proxy that would replace content. By doing that in burp, sounds much easier. Just a decent tip for getting kind of that widespread test. I mean, in this case, you're kind of looking for server responses that can't be trusted, so it's a little bit of an interesting case. But yeah, they went and found. Actually, trying to find where they actually talk about having done that here. Right down here, making sure I'm referencing the right post. Oh, but that's the first idea, just using a file you can upload as your target to redirect to. Um, which basically just gives you control over the server's response to any API request that you can redirect with this sort of client-side path traversal. The other thing that they talk about being able to do here is making authenticator requests, and I think this is one of the more interesting use cases because an application, when it's making these fetch requests to its own API, it's probably going to be including things like the authorization header, anti-CSRF tokens, or even setting like application JSON the header or content type header, setting that. That's going to let you potentially redirect to other endpoints that you could then actually abuse for something. Um, you don't get much control over like if it's posting or something, you don't get much control over the actual body or content of the data, but you are able to redirect to something if you can do something like provide all the parameters in the URL, doing that sort of switch. You can take advantage of it. Um, but it's still something to kind of be aware of, and I feel like that's going to be a good place to kind of look for this or look for abusing it. Um, and lastly, talk about using a open redirect. You have some sort of open redirect on the same domain. And that is the thing, because you're only modifying the path that it's going to, not the actual domain, you are still limited to like targets on the API or whatever it's actually fetching. Uh, but using that, you get a redirect to happen. If redirect happens on the server side, it's going to redirect and it's going to include all those headers they added in that redirect. So you would be able to expose that potentially to your own domain and get access like the authorization header or whatever. I mean, probably don't care if they set the content type, but if they set authorization, especially or some custom header with an auth token, that's something you'd be interested in leaking. So again, just good use. Uh, they then kind of go into 3 cases of actually doing this. One was, if you're watching, this will be pretty obvious. Language, and that's where it loads this locale's JSON file that gets put into the page insecurely. They were able to use. I think there was an image upload. What was there in this? Or no, this application just had documents of all kinds, so they could just upload a random document, redirect to their random document, and basically use that for XSS. They had another one API call. I'll leave it to you guys to actually dive through all of them, but it's basically taking those exploit cases from before, which I think are the main takeaways here, and just showing a few real cases. Of course, they don't actually give information about what websites or applications these were found on. So I think most of the value is just in those exploit strategies, especially if you took interest in the whole client side path traversal attack when we talked about it on episode 176, or maybe you were interested in it before. I think I mentioned that was fairly new to me. I mean, kind of one of those things that you're roughly aware, like maybe there's something to do there, but not something I'd ever dug into. So seeing some more work on the same research is kind of nice.
Yeah, it's a neat technique in how it works, and there's a lot of different directions you can go with it. I actually like the third case study that they got into here, where they like on this particular target they bypass CSRF protection by diverting a post request. Basically, just because the request is going to contain the anti CSRF header. They had like a custom anti CSRF header in there, but this vulnerable page would take an ID query parameter in the form of a UUID, and it was vulnerable to the path traversal, and you could use that to send requests to the more privileged endpoints, which would include the CSRF token. So it's another neat way that you could take advantage of this. But like you said, there's a lot of like details and specifics on the exploits that were found, like real world scenarios of it. So yeah, it's a cool post. It goes into a good number of different attacks that you can try to pull off with it. And yeah, I think client side path traversal is just kind of neat in its nature. We do have another post that talks about it as well. By Arasec, and it's another practical example of a client side path traversal, which I'll let you get into. Z.
Yeah, and this one, I don't think we need to spend a ton of time talking about, largely because it is similar to one of the flows that we did just talk about. In this case, they have a application, it's some sort of financial application. Again, they're not telling us where it was found, fortunately. Um, as you'd expect, no financial app. You can manage accounts, payments, cards. You have different user profiles. In particular, the kind of matters here are there admins who can invite other employees or contractors, whatever, onto the platform to create an account. And they do that. They kind of have this normalish looking invite thing, and they have an invite code. So when that invite code gets parsed, it ends up making this post to check the invite code to their API or backend, whatever. Taking that invite code, just tossing it right in the URL, so you can do a traversal there. And so you do that traversal, you get it hitting some other endpoint. Then it's just a question of, well, what endpoints could they get to using this post? And again, actually, I will mention this did have their anti CSRF token, so it's including that they're able to hit any any endpoint that they want. They just need one that would actually take a post with an empty body as this request. Um, Apparently would send, or at least not with the parameters that they wanted. Does look like it's normally sending it with the email, and then they're looking for endpoints that don't take it. Oh yeah, looking for a request to take empty or JSON body with single email. My bad. So yeah, they're looking for that sort of endpoint. They came across just canceling a card, which doesn't seem super impactful. Actually, I'd even question how practical this as an attack is, simply because the endpoint that they redirect to is this cards. You've got the UID and then slash cancel. So they're able to cancel it, but they need to know this ID. And I don't believe that ID is going to be very easy to come across. Um, Maybe something with brute forcing it. That would really depend a bit more on the application, how they're actually generating those values. But does like just looking at it, assuming it's random. I mean, I'm assuming this particular value they've kind of messed with a little bit to hide the true values. Uh, but assuming it's random would be pretty hard to predict, and they don't talk about being able to disclose that in any way. You would need to know an admin's card to actually cancel it, or someone's card to cancel it. Um, they do also make mention of finding like a page for a super admin, um, and a similar kind of endpoint they could abuse there. But I mean, in terms of the attack, it's very similar to what we just saw with the CSRF bypass, just an actual case for. Which is the thing with this sort of attack, it does open up CSRF even when you have same site none or um these sort or sorry strict. Even when you have some sort of extra protection there, these sort of attacks kind of open it back up with obvious limitations. So again, it's interesting. It's nice to see that basically two posts coming out very quickly. It feels like a newer sort of area for research. I guess other people also found. Yeah, actually, he does call out the post that we were talking about in episode 176. Calls that out as being kind of their inspiration, or I guess inspiration for writing about it, not necessarily for looking at it, but yeah, I mean, just another case of it. Interesting to see. I see the a bit more research being put out there about it to make it more accessible.
Yeah. All right, so we'll get into our next topic here, which is a Project Zero post on DER entitlements. So this is talking about iOS, and it's been a little while since we've talked about iOS entitlements. So for those who are unaware of what they are, they're basically Apple's fine-grained permission system, where an app can have one or more entitlements to what rights or capabilities they have. So third-party apps can only have certain, like a limited subset of entitlements, and those have to be signed off by Apple before it makes its way to the App Store. So it's how Apple manages the capabilities of what apps can and can't do. Um, so yeah, in iOS 15, they updated entitlements though, and they changed the format from a text-based XML format to DER, or Distinguished Encoding Rules, which is specified in the X690 standard and is a binary format. So of course, the library had to be added to deal with the DER entitlements, and this lib is used in both userland and kernel, so it's a fairly interesting target in that respect. But it's also fairly small, and it's just a single library, unlike the 4 or 5 that were used for XML. So overall, it is like a more secure move, moving away from the text-based XML parsing, where it was kind of a nightmare, and there were bugs in the past because of parser differentials with how many libraries were doing it. And this is moving to like a more sensible format in a lot of ways. So yeah, it's fairly small, and it is just in one lib, but it does implement traversing in a few different places for DER entitlements. Um, and this is where the bug starts coming into play.
Which I
Um,
thought was interesting, actually, is the fact that they're kind of centralizing around just having the one parser, or at least it seems like they're going for that, and then they still kind of screw that up by having multiple parsers for
it's
doing the
interesting,
traversal.
yeah. You would
Like I
think it
could,
would have been more centralized.
yeah, like I could imagine the case where multiple developers working at the same time. Oh, we don't have this functionality yet, therefore needing to implement it themselves. But yeah, I mean, it definitely stands out, and when you have it. it's just ripe for having some sort of desync attack, as we're going to see here. So I'll let you keep going.
Yeah. So I will preface this by saying some of you might have noticed we started a little bit later today, and this is kind of where we were having a discussion before we went live, uh, because it's a little bit like complex how the root bug works, because there's multiple lengths in play. So I brought up the image for those who can see. Um, so basically, inside of these sequences, you can have like a sequence length, and then you could also have these like the length of the values inside of it or the content length. Um, and it seems like there's a bit of a disagreement when it comes to the sequence length and how to treat it when you have a smaller sequence length but a larger content length. So, yeah, like I was saying, it's not really centralized. The way that DER entitlements are traversed is done in a few different places. So there's recursively validate entitlements, which is used for entitlement validation, obviously. Dir VM iterate for converting entitlements into a dictionary and checking if it's a subset, and DER VM execute no copy, which is used for querying the entitlements. So, as you can probably guess where this is going, these traverses are similar, but they're not exactly the same in how they're implemented, especially when it comes to handling that entitlement sequence length. So, while DER VM iterate would behave correctly, and upon parsing a key value sequence would continue processing after the sequence end if the content length was larger than the smaller sequence length. The other functions would ignore the sequence length though and would just kind of continue parsing after the end of the value instead of going on to the next sequence. So effectively, that allowed you to
Quick
smuggle
question:
entitlements. Yep, go ahead.
Are you actually so recursively validate entitlements? Does that actually do it correctly? I don't think he technically calls it out either way if it's correct or not. The two that seem
Um,
really in play are just the dir VM one.
Sorry, I'm just
Since you
doing a
mentioned
quick
the
check.
other two do it incorrectly, I'm not entirely sure about that.
Okay, yeah, so I read it as that was implied by saying that Dir VM did it correctly, but not calling
The
out
other
the
two
other
must
ones.
not. Fair,
Um,
yeah. I mean, I
Actually,
could
yeah,
get that
sorry.
reading, but I don't see it as explicit, so I didn't. I mean, I don't think it matters either way. Like, we don't really talk or. Oh, I guess you are pointing out that I am just wrong. They both completely.
Yeah,
Oh,
as you were talking, I just read into it and saw yet they do explicitly call out that they do like both of them functioning correctly. So
okay,
yeah,
my bad.
yeah, all good. Um, so yeah, this effectively allowed you to smuggle entitlements by embedding them as children of other entitlements because they'd be visible to the execute no copy for doing the querying, but it would be hidden from the functions that use DM or VM iterate, like the context is subset. To take advantage of this bug, they had to write some tooling that would craft the entitlements and embed them into the signature blob. And they also had to find an entitlement that was useful to smuggle in. They were pretty limited in that respect because a lot of the user space daemons that would have the more interesting entitlements were still using the old system that was XML based. So those kinds of entitlements weren't really open for them to use. Just kind of that weird place where not everything's transitioned over to using the DER entitlements yet. So that left them with the entitlement checks done by the kernel, of which they list some here. A majority of what they detail are done by Apple Mobile File Integrity to check if processes have entitlements. And the one that was reported was invoking the KX request API for kernel extensions, which normally you shouldn't have access to even as root. So it's a pretty privileged functionality, being able to gain access and give yourself the entitlement for that. Um, and yeah, so interesting bug, and it could have some serious ramifications. And again, where it is like one of those higher level bugs, and you're not dealing with something like memory corruption, it's pretty powerful because it's reliable and pretty repeatable. So yeah,
Yeah, this isn't
pretty high
something that's
impact.
uh going to crash on you. I mean, it works, or it's very stable. I do want to talk just kind of as a takeaway in general from this bug. It's one is just the fact they have the two effectively interpreters, the two things implementing different traversal algorithms, or three, I guess technically. The fact that you have multiple things doing the same thing creates that case for there to be a desync. Um, and in this case, I just want to point out a little bit that it's a little bit confusing because of the different length values in play. The way I believe this one worked is just because you have kind of every element in dir has a TLV, type, length, and value. The length is supposed to be the full length of just here's how long this value is. So every time you're processing one dir item, even if it has sub elements or whatever, like if you want to skip it, you just go, plus length bytes and jump ahead to the next thing. Like it's really simple to kind of jump ahead in that sense. Or you can go in and actually process that whole value. And then when processing that value, you have another value that seems to sort of count. It's the sequence length value. So they crave basically desync in terms of the value that they crave for here's how many bytes this thing takes up. And then when you actually process the length given there for the sequence, that ends up being shorter, creating this gap where you can smuggle in data because one keeps reading from where it stopped processing the sub entities, the other one actually skips ahead to the end of the container entity when it's done processing it. So that is kind of a common case that you do see in parsers. And a bit of a weird case to have the multiple lengths, but when you have kind of that desync between a container size and internal size, you can sometimes smuggle in content here. So I kind of want to call that out as just one of those cases to keep an eye out for. Yeah, I mean, this is very kind of internal to iOS, but you could see that sort of processing happen elsewhere. Just when you have multiple lengths, what can you do if they're not exactly what the application's expecting? It's something just to play around with, test, and see what happens.
Yeah, it can be a difficult scenario to handle properly as a developer. So, um,
Yeah,
yeah,
like
I
it's really easy to think that if this weren't a malicious set of entitlements, in theory, your sequence should end because I mean, during coding, part of that is also like keeping things serialized, not having some excess padding. So it makes sense that a developer would think, oh, I can just carry on once I'm done parsing and not actually validate that it's at the proper end. Um, I mean, it's an easy mistake to make when you're trying to implement this, just not really thinking about all of the consequences of that.
yeah, I thought I'd get into the way this bug was patched because it's kind of funny, but this bug was patched accidentally through a refactor, which was discovered when Apple asked P0 to try to reproduce the bug in macOS Ventura, and found that the DER parsing was changed, where they now take the parent DER as an input instead of the whole thing. I think they don't really go into a lot of detail on it, but basically, I think they made the parsing more fine grained. If that makes sense. I might be mistaken, but that's how I read it. So basically, just because of the way they refactored it, the bug wasn't really hittable anymore. But Apple did also put out a patch as well that added some additional validation to ensure a key value sequence doesn't contain other elements. Um, and I'll also point out as a sidebar that the post talks a bit about the fact that SHA-1 is still allowed as a hash type for Apple's integrity checks on the code directory. And they call this out as somewhat interesting because SHA-1 is vulnerable to collision attacks, as we've seen before. Specifically, like an identical prefix type attack could be interesting, where you could try to get like one set of entitlements to come out as at the same hash as another set, and try to do like a desync between AMFID's view of the entitlements and the kernels. They leave that to future research, though, but they say that they hope Apple just removes SHA-1 support for the integrity checks entirely, which honestly, I'm surprised that SHA-1 is even still supported at all. Because like with Apple, they don't really have to worry about legacy or breaking support or something since they control the ecosystem for the most part. So it's kind of interesting that such a weak hashing algorithm is still used in this sort of context. But I'm sure we'll see that change in some amount of time. But I thought I'd call it out because it is mentioned by the post. Like I said, they leave that to future research. They don't delve into that very much, but it is a potential avenue for future research. So
Yeah, it seemed like it supported it, but wasn't necessarily the main way it's being done. I'm not
yeah,
sure about that though.
yeah, that's how I read it too. Maybe it was used in some older iOS versions, and it's being kept for that. But uh, yeah, it's SHA-1 is a pretty weak hashing algorithm
I mean,
for.
it's not MD5. There are
It's not quite that bad,
problems with
but it's still
SHA-1, but it's
yeah.
still costly, I think. I mean, costly from an individual perspective. They talk here in 2020, the cost of an identical prefix collision was, $11,000 versus a chosen prefix actually saying I wanted to match like this other thing, $45,000. So like accessible on like some level, but most individuals aren't going to be able to drop that. That said, I mean, now where they're making some money off it, ransomware or whatever, I could imagine that potentially being reasonable.
And of course, nation state actors,
Yeah, I
which are
mean,
always in
that
the
was kind
conversation.
of I felt like that was a bit implied. Like, of course, nation states could easily afford, $50,000.
Yeah. Well, you would hope so anyway. Yeah. All right, so we'll get into our last topic here, which is Evolve in Android 13's hardened parcel serialization changes, which can result in privesc to system app. So it's kind of funny in this episode, we have two like mobile topics that are bugs that are results of security improvements overall. So yeah, this is another case of that. I'll let Z get into this one because this one was a little bit complicated, and I think Z has a better grasp on it than I do, because it's dealing with like deserialization and some of the stuff in the Java
Bit of
abstractions
it.
for IPC.
There's a bit of the deserialization, so they talk about that in the context of the older bugs. So, as Spectre mentioned, this was a kind of security improvement that was introduced. These lazy values were meant to end the self-changing bundles. Self-changing bundles. Um, I actually wasn't familiar with this attack, but seems kind of cool. The idea with bundles, it's basically just key value mapping. Some limitations on the actual values that can be stored. One of the types of values are parcel. Parcels kind of have this. It's not like an intentional feature, but it's a serialization method. You go through, you have like the dot right string, dot right int or whatever, and then when recreating the object from the parcel, it will read int or read string or whatever. Um, that kind of makes sense, but it didn't have internal size, so you could say, or even typing information there. It was just a binary blob effectively being stored, and it would kind of just track where it is. So you could have these unbalanced parcels, which would write, maybe more data, and then when it reads back, it would only read like an int, and it would have an offset, so it could read different data back the second time it gets read, which mattered because these bundles are meant to be passed around to different across process boundaries. You'd send that up to system server, send it out to wherever else if you're trying to do something. The gist of the attack was, or with self-changing bundles, is you'd send a bundle that uh some application would validate, or some service, sorry, would validate and be like, okay, these values are okay to use. And in doing so, it would unbundle the bundle, look at those values, and then rebundle it, send it back to system server saying, like, yep, this is okay to go. And then system server would unbundle it that second time, getting all these new values, something insecure. And in the case of the attacks, they were just using intents that system server could access, but that wouldn't have actually been approved by the application. Um, that's those attacks. That's what LazyValue is in part an attempt to stop those attacks by writing in the length information when it's writing a value. So with the value, it actually stores information about what the length of it is, so it can know when you read a value, if you read too little information or doesn't match the actual size of whatever was supposed to be written there, it knows. And then they added in the read lazy value, which goes into it a little bit deeper. So lazy values are effectively just a layer of abstraction on top of the, or as I understand it at least, I will admit I had to do a bunch of digging here, so my understanding may be a bit more limited here, but lazy values an abstraction on top of that where you effectively just have another class which holds a reference to the data that's supposed to parse, and then you can call like the get value on it to read the actual lazy value, or to lazily read the value, so reading it when you need it. Um, and in one particular case, so there's yet another functionality in here. It's string deduplication. So sometimes the objects here are going to have repeated strings, so they have this fancy little helper that does string deduplication. Doesn't really matter how it works. What matters is when you have that enabled and this parcel comes through, it's going to decide to just immediately deserialize it. It's not. It's going to try and resolve all those lazy values and everything in there, and just immediately get all the real values. That way, that object doesn't need to stay in memory very long. It can just be used up, and they'll make a clone of the parcel, that, and that's where the problem comes in, or part of the problem comes in. Um, I guess one other bit of background that should be mentioned, and actually where I think this vulnerability is kind of cool, and probably more where the takeaway is these parcels aren't in like the normal Java memory system. Well, they are technically, but they're part of a pool. So as parcels are allocated, they end up in a pool, and then you just pull out the pool rather than actually being completely freed back to like the Java garbage collector finding it and freeing it. They stay inside of this pool, which creates the possibility for a sort of use after free. Or well, they call it a use after recycle in this case. So jumping back, when the parcel, if it has the string deduplication going on there, it's going to try and resolve all of those lazy values. And those lazy values are effectively just objects with references to where the data actually is in the original parcel. Um, so to be clear, a copy is made. It then tries to resolve all the values in that copy. Um, all those lazy values still point to the original, and as it's iterating through, if any of those lazy values fail, and they talk about introducing a failure, how that might happen. But if any of them fail, specifically at least how the system server runs, it won't raise an exception. It'll just ignore it and leave that lazy value in place. Which means you can end up having an object that it thinks has no lazy values left. That's completely unparceled and resolved all of the values in it. But instead, it actually does have a lazy value in there, and it's still pointing to the original parcel. Later on, that original parcel, because it's made this copy, it no longer needs the original, and it will recycle it, effectively freeing, just putting it back in the pool for somebody else to use, creating your scenario where you get a use after free. When that gets used again, this parcel gets recycled, somebody else uses it, you can now get control over the value as it's being loaded, another time, or where it's getting used somewhere else later. So I thought that was a really cool attack. Just the memory pool allocation, kind of seeing this sort of use after free style attack inside of Java. You don't really see that. I mean, unless you're looking at attacking the Java runtime, you don't really see that. Um, yeah, like that's the gist of it. They do go into exploiting it, which I'm not going to go into, largely because that's just Android specific stuff that, unless you're actually dealing with Android, in which case it's probably not all that new to you. Uh, but in terms of the attack, seeing that sort of use after recycle attack, it's just another place to keep in mind to look at when something tries to implement any sort of memory management. This is true when you're looking at CS too, but it's really hard to get that right every time. And in this case, uh, I mean, I'm not even sure with the lazy value holding that reference back into the old object. You just have to be aware of that edge case and like not let it happen. Either let the exception be raised and not try. Well, there are other problems with actually doing it that way too. I assume they have some patch information here. I didn't actually dig into it, and I probably should have. Look at how they did try and patch this issue.
I did
Nonetheless,
take a look at the patch at one point. I think it's basically they'd always called recycle with true at one point, and I think they made it so that it in
no, I
damn,
think
I
you're
can't remember the
thinking of
exact
early on. It talks
patch.
about basically recalling or not running the initialize from parcel lock, and it would run recycle parcel equals false. I think that's what you're thinking of when it comes to the true false value.
So here's what I was thinking of. I just brought up the patch for those who can see it. So yeah, they added this comment: recycle parcel being false implies that we do not own the parcel. In this case, do not use lazy values to be safe, as the parcel can be recycled outside of our control. So you can see before they just always set lazy to true, um, and now they check like recycle parcel. So
Yeah, okay, different area too. I was saying
yeah.
different area of code.
So I couldn't remember the exact specifics, but now the code is up. Yeah, it's basically They were treating values lazy even when they didn't own the parcel at sometimes, and that's why that's what the patch aims to address.
Yeah,
Um,
fair enough. Better than some of the things I was thinking of. Um, but yeah, I mean, in terms of a bug, and in terms of takeaways, it's those custom memory pools that get implemented. You can have these sorts of issues. So taking a look for odd flows, unexpected flows. In this case, it is kind of a special edge case that goes through and makes that copy and kind of does this extra bit of work specifically uh on having that string deduplication enabled. Like I, I mean, edge cases are always a place for bugs, but yeah, I mean, I've never. I'm sure this has been seen elsewhere. Um, like it's not a new attack. It's not something I've actually found. Doing my consulting, I don't think I've ever called out any sort of issue like this. Um, in part because I wasn't necessarily even thinking about it. Thinking after, the memory pool and that, like keeping a reference there. It is a bit deep. It would be hard to detect in a lot of cases, especially if you're a black box. Um, but really interesting to see nonetheless. And at least for me, a bit of an eye opener here on just looking for that sort of issue. Again, I mean, maybe you already knew about and already looking for it in Java apps, in which case, fair to you. But novel to me, this post honestly doesn't do a great job of explaining it. There's a ton of background here. It's just really dense. You could see if you're watching, you could see just all these links out to other resources that you might want to read to understand a little bit better. Like there's a lot of links through this. It's very dense. It very much just assumes you understand exactly like what's going on, which in fairness, if you're writing it to that audience, nothing wrong with that, but B, not understanding like even some of the fundamentals of this made it a little bit hard to actually read. Um there were a couple things that did help me, and I'll just include their links here. One was this first link is about just bundle issues and like the self-modifying bundle or self-changing bundle. It's 2017 bug. That kind of helped me understand what was going on with that. And then there was a Black Hat Europe 2022 uh, talk, which is where they end up talking about where they end up talking about this new LazyValue, and they end up going through some of the issues that existed with parcels before and the mismatch parcels, and kind of how some of those attacks work. So it seems interesting. I'm actually looking forward to seeing the talk about this, but that has not been released yet. We just have the slides right now. But the slides do a reasonable job here of actually talking about some of the issues. So I'll include a link to that in the show notes also.
Yeah, I could see a lot of potential pitfalls with doing that, like manual memory management on top of Java's, automated garbage collected memory, which makes me wonder, like, why do it? It has to be like
Performance.
some kind of performance thing, yeah. But I don't know. It seems like the risk would almost outweigh like the performance benefits. But you know, I'm not
I mean,
gonna
if
have the
they
hubris to think I know more than Google, but it is like a very risky thing to do to open up this class of issues.
I will say this, so I don't know for sure about Parcelable or about these classes, but it does feel like in a lot of cases these had concrete values. They wouldn't have had references out to any other objects. And without any references, you don't have as much. I mean, you could have like a double free sort of situation, I guess, and then have two users of it. But at least the risk from this issue is really in having that reference in there that then hangs out too long.
Yeah,
So without that, like a pool isn't necessarily a bad idea. You don't have to go through the whole allocation process every single time, especially with some of these that are you're passing these across processes, so they're supposed to be rather short lived. Um, you see that actually that's one of the places where I've seen just custom memory allocators also being implemented is where you have just this one type of object just needs to be passed really quickly, passed along there. Um, and it's always like the same. I guess yeah, that is one things I'll see on the C side of things is it's always the same sort of object. a map doesn't feel like it really fits at it's usually like the same size. This would not always be the same size of objects, so a little different there. But yeah, it's got to be for the performance reasons, I suppose. I mean, especially system servers probably. Yeah, I guess I can't really go too far into exactly their reasoning. Performance, obviously, and one of the cases I see is just where you have the same object over and over and want to improve performance in that one hop path.
I would be curious about how much it does impact performance. Obviously, it's not talked about in this post. It's not really relevant for the bug or anything, but just like on a personal level, I would be curious uh, on the justifications of doing that. But yeah, it's kind of interesting. You don't generally see these kinds of reallocation type issues at this level in Java, but when you do
Yeah.
see it, it's really cool. So.
Yeah, that's why I really wanted to cover this post was just the sort of use after free sort of situation in Java is something to at least be aware of to hunt for.
Yeah. All right. So, with that topic out of the way, that's everything that we have for the episode today. So, unless you have any last minute thoughts, C, we'll go ahead and wrap it up.
Yeah, no shout outs this week.
All right. So, thank you
Actually, I
everyone who
will
tuned in. Oh, okay.
sorry. I wasn't planning to give the shout out. Uh but I figure I did on Twitter, I think already. Might as well do it here. And that is, at least for those of you listening to our podcast, you may also be interested in the Critical Thinking, a bug bounty podcast. Oh, thought I sorry, let me just copy the link here. I was unprepared for this. I have one episode out. I have a few more. Like they talk a bit more on the practical takeaways side of testing for issues. They've only had one episode so far. I enjoyed it. Like I can definitely recommend it. At least as a shout out, worth taking a look at if you're looking for other kind of more technical content. They don't dive into the code as much as we do, but I don't think audio is a great format for that. So they're probably making the right decision there. But other than that, I mean, more discussional. I enjoyed listening to them. I'm looking forward to seeing a few more episodes out of them.
Yeah. I don't think they're super regular. Like, I don't think they have a schedule, but they do mention they have a few more episodes in the pipeline. So, those will be dropping soon, presumably. And yeah, like one of the reasons we started this podcast is because we thought there was a lack of uh, audio video content covering this kind of thing, and I think that's still kind of true. So it's nice to see more podcasts coming into the space around vulnerabilities and whatnot.
Yeah,
So
especially on the
yeah,
technical side. There's a ton of like security, what's going
like
on right
NetSec.
now in security, but
Yeah,
yeah, I guess more NetSec, but it's nice to see more technical content actually doing the testing and doing all of that. Nice to see.
yeah. All right. So yeah, thank you everyone who tuned in as always. VOD will be up on Twitch immediately or on other platforms like YouTube tomorrow. And you can also find previous podcasts up on Spotify, Apple Podcasts, and more links on Anchor. Feel free to join the Discord and follow us on Twitter. Once again, the Spot the Bone challenge is there for anyone who wants to take a crack at it. Uh, Links for Discord and Twitter are down below or in the chat. And we'll be back tomorrow for the binary episode. That's at 7 p.m. Eastern, 4 p.m. Pacific. And we'll see you then.